Hi guys, Nate here from Reach 3D Printers. We're doing the rocket ship. There are a few things going on. I'm printing on glass again. I used the same PCB to level it. I hairsprayed off of, took the glass off, hairspray it, and then put it on there. Somebody mentioned that in the forum, and it's safer that way to prevent the nozzle from getting hairspray in it. There's a problem with this print. The actual STL had some problems with the code, and so the inside piece wasn't properly modeled, and it made part of the model disappear on the inside of that main booster. So I got a feeling that I just printed this and it failed. It did pretty well. It started, and it did these guys, but the problem was I think some of it must have caught and snapped these guys off of the little feet. So it basically ruined the print because one of these, in fact it was this guy, snapped off, and then it was printing all crazy like. And I think part of the problem was that inside piece. So I'm kind of trying to make sure that inside piece doesn't rise up and leave debris that then would track over and snap one of these guys off. I'm printing at, I think this is either, I think it's 0.2, it might be 0.25 rocket ship in PLA at, I've really slowed the feed rate down. We're probably only going about 30 millimeters a second. I slowed it down for right now because I'm going to make sure that these guys work. It sucks whenever you're in the middle of a print and you get pretty far and then all of a sudden something goes wrong. Well, you can see inside here, this is that main piece, you can see that ball of material in there. That's what happened. It's not connecting inside, and that's a problem with the model. I would have to go in and fix it, and I just, I've got a lot of stuff to do, and I don't really have the time to fix a really complicated model. This model is, like 500,000 faces, and maybe there's only like 50 problems, 50 little line segments that have some issues, but that could take like an hour, which I just can't afford. So I'm just making sure that this prints well and that interior model issue doesn't affect the print. That's why I kind of started this video a little late. I want to make sure it got off to a good start. So we shall see. Otherwise, I'm going to go ahead and go into a time lapse, and you might see my hand jump in here to make sure a few little pieces are held down, especially that center part. I'm not happy with whoever modeled this. I mean, it's a great model, but maybe just Cura read it wrong or something. It looks like it's starting to work out. Looks like the top center of this is starting to come together and bridge properly. Cooling also is probably partially, could be responsible for it. I wasn't here when it failed. It could be having to do with not having enough cooling, so I tilted the fan down a little more to try to cool the part a little better to prevent the warping of maybe these overhangs on these little feet. Maybe as it started getting higher and higher, one curled up even further and the nozzle caught it. That's possible. So cooling might be the culprit on that. I can almost see this one's the one that doesn't get cooled as well, because like the fan's blowing across this one right now, but this one is kind of out of the reach of the fan. Maybe the back one, but it's definitely sticking well. It just snapped off right there. Let me show you the end result. So it was one of these guys. It literally snapped off at the little footing. So I've slowed the print down to make sure that it's going to work out. And some complicated models, I mean, this one's got some pretty extreme overhangs. Some of those extreme long overhangs can be a little bit of a challenge if the G code isn't sliced really well. So we're going to find out. Like I said, you might see my hand, or you might see this little guy jump into the video to try to make sure that nothing's curling up. But sometimes that has to be done on you know, a key area that is critical to bridging or something. If your slicer settings are really nice, then you don't have to do that. But if the model has issues, then you're battling a model and mixture of slicer settings. So this definitely isn't the easiest thing to print, but it should really do okay as long as the interior doesn't mess up and I got some cooling. I think we're going to be okay. Okay, off to time lapse. Hey guys, I just wanted to talk a little bit about what's going on here. I believe what happened on my first print is, if you'll notice, the overhang there is like, it's like 80 degrees. I mean, that is a crazy extreme overhang. And something I noticed about the first print that failed, it was about right here that it snapped off that collar. And my guess is the extreme overhangs here are so extreme that it must have snapped off right there and then pulled that centerpiece into these legs. I think that's what must have happened. So what I'm doing, I've slowed down the speed to 40% of 50 millimeters a second. So we're going at like 22 millimeters a second right now. And then I'm taking my palette knife or scraper, whatever, and as soon as it's done printing that centerpiece, I mean, this is, I guess you could say this is kind of cheating, but I'm cooling it and pressing it flat as soon as it's done printing that layer. I won't have to do this once we get these bridges built. Once these archways are completed, it should be good to go. I put that board back there so that you could see how extreme that overhang was. I mean, I think printers generally can print somewhat extreme overhangs, but you have to generally slow down in your print settings. You have to indicate that it needs to slow down on something like that. Your other option is to print with support or structure. I hate printing with supports and structures because it's just a click of a button. You just say add in support and you're done. But I hate doing it because it makes prints take twice as long. And then you also have these little tiny attach points that you have to like clean up, and it doesn't give you as clean of a look. But if you have a really challenging print, like something like this is, yeah, it's not crazy challenging, but it's up there. Those overhangs are pretty extreme. And let me move the camera a little bit, so if you don't like a shaky camera, I'm sorry. If you'll notice that overhang, it is pretty intense at one point, like literally like 80-degree overhang. So that's what I'm competing with. It looks like the feet, these guys are actually fine, but I wasn't expecting that overhang to be that extreme right there. And you can see it kind of curling up. I think with better, I really believe with better cooling, that is something that can probably be eliminated. The problem can be eliminated. But here's where we're at. So I'm going to go ahead and go back to time lapse. I just wanted to throw that in. Hey guys, I just jumped back in because it's finally bridging. This is an insanely extreme print. I believe the problem was that these corners were peeling up because of improper cooling. So this printer definitely would benefit with another fan. These are some extreme overhangs. They are really, really extreme. And a printer, you know, it should be able to handle overhangs like that. Man, those are some really extreme overhangs. I really feel that with a second fan, or with a fan that cools the part directly at the nozzle, that would be solved. And you know, if that doesn't solve it, we still have other options. You know, if you've tried this once or twice, and even with better cooling it doesn't come out, then you're looking at support structure. Support structure builds scaffolding, and the part prints on the scaffolding. It holds everything in a lot more solid. And yeah, you'll have part cleanup where you got these little notches and stuff, but you get the part to come out, and that's part of the trick, is getting the part to finish. But for the most part, get it to focus on it. I'm gonna have to put it up against the table itself. I was gonna try to put it on the table. It's not want this day. Anyhow, the bridges are being done. It's definitely, I mean, it looks like there are a few stray strands, but we can work with that. As long as those bridges get on there, then everything starts locking into position and becomes a lot more solid. A little curl up may not be such a big deal on most prints. Just a second. A little curl up typically isn't a huge problem, but on something like this with such tiny little feet, tiny little connectors that are really weak and can snap, if like a lot of side load is applied to them, it becomes a problem. I've also reduced the speed of this print. You can see it's at 40%, really taking it down. As soon as it builds up some pretty solid bridges, I'll take that speed up. But I wanted to be fair and kind of tell everybody what's going on with printers as far as that's concerned. A lot of people think you just put the file in there and you just hit go. And to some extent that is true. You shouldn't have to babysit them. You shouldn't have to use a scraper and tap them down or anything. And I think with proper cooling, I keep repeating this, but I really feel that with proper cooling, that problem should be eliminated. But worst case scenario, you got to click add supports when you slice it, and it slices in some extra code that builds scaffolding to help everything stay solid. So that's where we're at with it. At this point, I really feel like this, the hardest part's done. That was just an insane overhang. Those are like at least 75-degree overhangs, if not closer to 80. I mean, those are extreme, and they stretch a pretty good distance. So this is a challenging print. Benchy ain't got nothing on this one. This one's crazy extreme on those. So whoever recommended I print out the rocket ship, they did their homework. They knew that it was not a super easy print. But I think we're in great shape now. So hopefully you guys enjoy the rest of the video. Hey guys, we're back. We're at the very end of the print. I've been running this at 80%, so about 40 millimeters a second, 42 or something. The slower you go, the better the prints. I put on there 60 to 90 because if it's square and simple enough and you're not doing anything really complex like this, you can definitely push into the 60 to 90, but if you want the best results possible, I'd recommend like 50 or below. The slower you go, the better you get. So just wanted to do a quick look at this thing. It's looking really cool. Some kind of design on the window. I've never printed this before, but it looks like there's some stray strands, but we can get those knocked off there. The actual top little spire, oh, there it goes. About 2.5 hours. Oh, it clicked because it ran into this board. Looked like about 2.5 hour print. I slowed the very first couple layers down, so for removing something like this with multiple parts, I really recommend being really careful with the removal process, because it can be pretty easy to snap stuff. So this will be a good example of how to carefully remove a print. So you're gonna need one of these scrapers. They're pretty inexpensive. This is kind of how I go about it. I'm just barely tapping the bottom until it breaks free. And then the main part, the one piece that's like what holds it all on there, that was it. Sometimes you have to get really under there and pry stuff up if it's got a lot of surface area. But if it's just a few connectors, that's how I would recommend doing it, just tapping it until it breaks free. And remember that piece that was underneath this cone, that's the piece that didn't attach. So here's the print. I'm just going to pull off a strand or two. I can leave them on there, I guess, just to show you what exactly. I got a second light right beside me, so I can see. Really easily, and that way I can show the print a lot better. All right, there it is. Now, if you notice those little zoom, those are artifacts from speed or ringing, and probably from pushing the speeds a little on the faster side. Let me get this turned so that you guys can get a really good look at it. So there's some strands from oozing. Usually those can just be snapped off. Maybe it'd be better if now the nozzle's still hot, but I think I can tilt that against it, that way. Shouldn't have any problems. See that little spot there? So also this looks like there's a gap in the layer, but I think it just melted a little bit more than the rest. You can also see a difference when it travels faster. The plastic goes more into a glass state, like a glass transitional state. So you can see when it travels slower, more heat affects it. And so from like right here down, you can see there's more reflection, and from there up, there's less reflection. So that's based on how fast the nozzle's moving. Let's see, yeah. So here's that inside part that just didn't print. Get the old contrast on here. It just isn't wanting to work with me. Anyhow, that is it. It looks pretty good for the most part. .25 was the layer height. Now check out like stuff like that right there. That's because whenever it's zipping around and it completes a layer, it'll jump up and start the next one. Well, it has to start somewhere, and then it jogs in and does like a second shell, or jogs out and does a second shell. You can change that in your settings to randomly designate where those start and stop, but I'll show you. Like this definitely isn't randomized. Not sure how this contrast is going to work out. I don't like that board. Seems to be delaying or altering the... there we are. Okay, you see this whole line down this thing. That's because it's all starting and stopping in the exact same spot. And you can see under the prints, these overhangs are looking a little rough because I didn't use support and because those are extreme. But there's a little strand on there. Other than that, it's a pretty solid part. I only printed it at 10% infill. I'm sure you could break these if you tried, so you wouldn't want to like really put a lot of oomph on it, but it feels pretty good. And then I think the top nose cone is supposed to stick in there or something. But yep, there it is. And show maybe some details of the print. That window came out pretty decent. It looks like a few of the little rivets, you know, there's like a triple rim on here, and some of those rivets interacted with that rim a little strange, but I don't know what shape this is. There's some kind of a weird logo on that. I don't really know. I just have to look at the design. Everything else looks really smooth. These came out really well. Kind of a cool print. I dig it. It looks like a Y, possibly, or a G. Yeah, that's a G. Well, there you have it, guys. Pretty clean overall. You know, aside from the overhang issues that we were experiencing early on, those overhangs being, that piece just is wanting to hang on there. You know, the overhangs here and here, that is that's where the challenge was, but they came out pretty good. I did take that palette knife and kind of try to smooth it down, but you know, pretty good overall. Again, the second fan, I'm going with that. I think that second fan will really resolve almost everything. I'm probably moving this all over the place. Alright, well, this is the last print for the print requests for Kickstarter, and we've only got like, you know, 2 days left on the Kickstarter. We are kicking butt. It's gonna be awesome. So yeah, that's it. Hope you guys enjoyed the little Gcreate rocket ship. It was about 2 hours and 30 minutes to print that. Of course, to do those overhangs, I think slowing it down a lot, down to like 25 millimeters a second, is probably a wise idea. Plus cooling should make it better. Or if you just want to throw on support structures, it's a click of the button in your slicer program. When you slice with Cura, just click a single button and it throws them in there. So there you have it, guys. Thanks a bunch. See you in a little bit.